Hi Logic students, this is a second recording for section 6.3. I wanted to show you how to work the exercises in part 2. So these are your exercises in part 2, and this particular exercise is number 4 in part 2. Here the task is different. In part 1, the task is to build a truth table for a statement and then determine whether the statement is tautologous, self-contradictory, or contingent. Um, this other kind of exercise that we're about to do is about the relationship between two distinct statements. There are two different statements here. There's R or not S, and there's S and not R. So these are separate. There's no connection between them, so we keep them separate from each other. But if we do a truth table for both statements at the same time, we can discover any relationship that the statements may have to each other. For example, it's possible that the statements are logically equivalent, or that they're contradictory, or that they're consistent or inconsistent. So first you check to see if they're equivalent or contradictory. If you don't find that relationship, then you check to see if they're consistent or inconsistent. The book explains that equivalency and contradictoriness are stronger relations than consistency or inconsistency. Let's see what happens with these particular statements. What you want to do is, as you always do for truth tables, first you figure out how many rows the table will have. And you can see immediately that there are two types, type R and type S. So type R has 2 tokens, type S has 2 tokens. So you have 2 types of letters. So you write down the number 2, and then you use 2, the number of types, as the exponent. 2 to the second is 4. So you know that you're going to have 4 rows to this table. 1, 2, 3, and 4. Then you use the same method that you used with the other exercise that I did a video for. You split the 4. So under the first letter you put 2 T's and 2 F's. And then very important, you do this for the other R as well. 2 T's and 2 F's. If you don't have this consistency, the table will not be properly set up and it will be wrong. And then you take the 2 T's and 2 F's and you split it again for the S. So you go to 1 T, 1 F, 1 T, 1 F. And again here, you need to be consistent. TF, TF. Okay, the second thing that you want to do is now you have a negation that applies directly to the S and a negation that applies directly to the R. So you want to compute those negations first. And you know that the negation sign simply reverses the truth value of the statement that it applies to, or the formula that it applies to. So here you have TF, TF. So under this tilde, you will have FT, FT. You just reverse it. Here you have 2 T's and 2 F's. So under the tilde, you will have 2 F's and 2 T's. Very important, now that you have computed the truth value of the negation, given that the two components of this disjunction are R and not S, these become irrelevant. You can forget about these. They don't play a role in your thinking anymore. And similarly on this side, these don't matter anymore, so don't even look there. Now you have to compute the truth value of the disjunction from the value of R and the value of not S. And these values are written under R and under the tilde. It's a disjunction. You use a truth table for disjunction. True and false makes true. Both true makes true. Both false makes false. One false, one true makes true. And then you go on the other side and do the same thing, but now you have and, or the dot, as your operator. So you use the truth table for the dot. One true, one false. It's false. Both false. It's false. Both true. It's true. One false, one true. It's false. The truth table is complete, and what you want to do is look under the main operator in the first statement and the main operator in the second statement. So you focus on those two columns and you compare them to see if there's a special kind of relationship between these statements. Okay, there's nothing else to do. Don't be tempted to write anything in this area. That's completely empty. There's nothing to write there. You're simply comparing the truth table for this statement, or actually the column under the main operator in this statement, with the column under the main operator for the other statement. And let's see what happens. This one is true and this one is false, so they differ. True and false, they differ again. False and true, they are different again. And then true and false. The two truth values always differ, row after row. When one statement is true, the other is false. And when one statement is false, the other is true. So that means that these are two contradictory statements. They contradict each other. One is true, the other is false, and vice versa. So we have discovered a particular type of relationship between these two statements. I hope this is clear. There are obviously other exercises in that section, so try some of those in the forums and let me know if you have any questions. Thanks.